Hi, my name is Matt Thompson. I am the global head of EC2 Spot. And what we're going to be talking about today is basically how can you get more out of your EC2. So whether that means basically maximizing your price considerations or your capacity optimization, that's what we're going to be discussing. From an agenda perspective, first we're just going to talk a little bit about the history of EC2 and some of the foundations and the taxonomy just to kind of get you into the right mode. Then we're going to go into some of our pricing and capacity possibilities in terms of products. We'll give you a little bit of guidance in terms of Compute Optimizer. And then ultimately, we'll give you a couple of workload examples to show how you can kind of blend pricing models to basically just really eke the most out of EC2. So let's start with a little history first. 13 years ago, basically, we introduced the M1 to the world. So we just started with one instance type and size. Basically had one vCPU, 1.7 gigabytes of system memory. And one of the more important kind of business model innovations, if you get there, is basically we introduced the ability to pay for what you used, so on demand. So you could actually spin up and spin down instances without kind of having to rack a bunch of servers and think really long term. You just kind of paid for what you needed. And today that's our, as I said, on-demand business model. Fast forward 13 years, 2020. And we now have the broadest and deepest platform, if you will. What we've done is kind of just learn from our customers that they really wanted different instance types and sizes just to do different workloads. And so we can kind of confidently say at 300 plus instance types today that we have an instance type for every kind of workload or business need that you might have. We actually just believe that kind of more choice equals better performance. Don't forget, we also kind of have networking in here. Networking up to speeds of 100 gigabits per second, and then storage, volumes, EBS or Elastic Block Store, super fast, secure storage. That's kind of the macro view of instances. When we look at the micro characteristics, I think it makes a lot of sense to just spend a couple minutes on the characteristics of an EC2 instance. And so they're all a blend of CPU, memory, storage, and networking, if you will. And that kind of makes up the family, that like unique blend or weighting, if you will. But so let's go a little bit through this whole instance type taxonomy on the right-hand side of this slide, just to kind of level set how you think about when you're looking at an instance so you know what you're looking at, right? So the left-hand side, like the M, is just the instance family. In this case, it's kind of like a general compute or general use instance type. We also have the instance generation. That's the 5 in this case. If you remember, we started with the M1, and we're now on the 5th generation. You'll see us talking about the M6 in a couple of minutes. Then you get this additional capabilities. Let's call it small alphabetic character. And in this case, the D just means that the instance storage is physically connected to the host server on this instance type. So these little additional capabilities will have different unique values, if you will. Like this instance store being physically connected. And then we get to the size. And the extra large, for example, has basically 4 vCPUs. The t-shirt size, so let's say the 2XL or the 4XL, each time those double, they double in processors. So for example, a 2XL will have 8 vCPUs and a 4XL will have 16 vCPUs. So that's the way to think about kind of the characteristics of one of our instances. Really quickly, let's just go through the instance types. And basically, we have some general purpose instance types we can just talk about. General purpose instances are great for workloads like web applications and small databases. And so we've had the M around for a while, and that's what those general purpose are usually used for. We have memory optimized instances, most notably the R types. And these are great for large amounts of data in memory, like NoSQL workloads, like MongoDB type stuff. You may want to process, for example, unstructured data for web personalization, and that's where you really might want to use an R type so that it's memory optimized. We have compute optimized instance types, and these are great for high performance processing. So workloads like ad serving or media transcoding are really great for RC type instances. And then we should spend just a couple minutes talking about our Graviton instance types. And basically, these are, we announced the initial Graviton 1 processor type as the A1 back in 2018 at reInvent. In 2019, at reInvent, we announced that we were going to come out with Graviton 2, kind of our next generation of the Graviton processors. These were actually built out of kind of our acquisition of Annapurna Labs. And what's been really interesting is to see the difference in the Graviton 1 to the Graviton 2. The Graviton 2 today actually delivers up to 7x higher performance, 4 times the number of compute cores. So this means that Graviton 2 is more ready for workloads like ML or video or HPC type workloads. And then it also has 5 times faster memory than that previous Graviton 1 generation. So it's interesting to see what we've done. Just recently, we announced that we would be releasing the Graviton set in our kind of general instance types. So these are all actually now generally available. We actually have the M6G, the C6G, and the R6G. So these are just basically backed by now our Graviton 2 processor. Basically, this is interesting from the standpoint of we see 40% better price performance ratio on the Graviton-based processors as opposed to our last x86, like M5 series, for example. And so we actually did do kind of a test with using that SpecInt 2017 benchmark, which actually tests like Perl, compiling code, Sudoku solvers, et cetera, just to look at the compute, and found that we actually had a 44% higher performance on the M6G versus the M5. So what we're really hoping is that we can pass on some of our innovation and save you kind of money by giving you better price performance ratio on the Graviton processors. So those are available today. Just to kind of quickly round out our instance types, we have storage optimized instances. This is more just so you know. We basically have, these are great for like workloads that need heavy I/O operations on local storage, large data sets that need a lot of read or write in the NoSQL world. Our I3s, Ds, and Hs are great for that. And then we have kind of the AI/ML set, if you will, these accelerated computing instances. We have the P series, the G series, and some FPGAs. Great for stuff like floating point calculations in the finance world, HPC workloads like computational fluid dynamics, and then, of course, AI/ML workloads like deep learning. Great for the P and G series, for example, here. And then we actually announced one more thing that we think is very interesting, super purpose-built instance type, which is the INF1 instance. And this is specifically for prediction or inference in the AI/ML world. So anytime you need to make predictions, these are going to give you basically the lowest cost per performance, or the way we like to say it is 5x lower cost per inference than any of the other GPUs we have at Amazon. So these are very purpose-built, the INF1. So as you can see, just in that, let's say 9 or so minutes, we have quite a few different instance type sizes, as I said, 300 plus. And so it can be kind of confusing now that we've kind of, let's say, listened to the customer and started to build for very specific workloads. And so what I want to do with the remainder of the time is just to help you kind of optimize the cost and capacity management on some of this complexity. And so we're going to do that in 3 ways. We're going to talk about pricing, then we're going to talk about capacity optimization, and then we're going to talk about guidance. And so I'm going to focus on some specific new pieces here, and you'll see this in pricing. So let's just jump right into the EC2 purchase options. So on demand, we talked about at the front. So this is basically a pay-as-you-go model. We always have this available in the cloud. Frankly, that's the promise of elasticity, right? So on-demand pricing model, and that is pay by the second. With reserved instances, we offer the ability to pay for a longer term, but in exchange for a very solid discount, right? And that's reserved instances are pretty well known. So on-demand and reserved instances are reasonably well known. I want to get today more into savings plans and spot instances, which are a little more emergent in terms of our pricing models at EC2. So savings plans are very much like reserved instances, but offer a little more flexibility in exchange for an hourly commitment to spend on those instances. With spot instances, very different. They're actually less about workloads that you know are going to be on all the time, and more about workloads that are going to scale up and scale down quickly. And this is actually our spare capacity. And with spot instances, they are 90% off of on-demand, or up to 90% off of on-demand. But they have some certain caveats, and I'll get to those in a little bit. So let's spend a little more time on the latter two, savings plans and spot instances. All right, so let's talk about savings plans. Savings plans are great for workloads that you know are going to be on all the time. They are steady state. So let's say a database never can go down. You got to be running your compute power at all times to support that database. Great place to put a savings plan. Not unlike a reserved instance, savings plans are kind of a longer term commitment in exchange for that discount. And I want to go through the two savings plans types we have. So first I'm going to actually start on the right-hand side. The one thing you're going to note with these is basically they're a little more flexible than our reserved instances, and I'll call those out. So on the EC2 savings plan instance side, these are our most discounted savings plans, up to 72% off on demand. The one difference that they have, so again, it's a commitment of an hourly spend, but the one difference they have that's key from reserved instances is you no longer have to select exactly the instance type and size that you think you're going to need for, like, say, 1 to 3 years. What EC2 instance savings plans allow you to do is, let's say you started off and you said, hey, I think I really like an M5 XL because my workload works really well on those, and you want to start a savings plan for that. Maybe later on you re-engineer your application a little bit. You realize that it actually works better on M5 4XLs. With the savings plan, the spend is the same, and you can totally change that underlying instance type that you're using. So that's one of the benefits of the EC2 instance savings plan. And obviously they have 72% discount off of on demand. So if you have a steady state and one instance type, great, or instance family, that's great. Compute savings plans are a little more flexible. They offer you basically the ability to change families, regions, and even kind of some of our managed services. And those aren't quite as deep discounts, 66% off or up to 66% off, but they allow you to actually change families. So let's say you started with an M5 and then you realize you needed a more compute intensive instance type like a C5. You can actually do that in this type of savings plan in the compute type. You can also change regions. Let's say your business needs change. 2 years from now after you start, you might want to change from, say, like the Ireland region to the Mumbai region and use your compute in that region instead. And you can do that with compute savings plans. And then the last, it actually allows you to use even kind of our serverless functions like Lambda and containers, and actually have your savings plan apply to use in those areas as well. So if you're going to use some of those serverless managed services that we have, you can totally do that with the compute savings plan. So that's savings plans. Again, very good for a steady state workload, right? You know it's going to be always on. So let's get to the opposite end of the spectrum, and let's talk about spot instances. So spot instances are very much more like on demand. You can scale them up, scale them down, and so they're great for things that aren't necessarily steady state or you need to burst frequently. They also carry one major caveat. So spot is actually our spare capacity. So what you're really doing is leveraging the scale of AWS EC2. Think about like Black Friday, for example. If like we always have to rack enough capacity to make sure that like our customers are served during Black Friday so they can serve their customers as shopping increases. Well, we always have that capacity lying around, and so we actually sell that as spot. It's our spare capacity. The one caveat on spot is if we need to take that capacity back to you to serve a different customer who's willing to pay an on-demand price, we give you a 2-minute warning and may take one of your servers back. So that means that you need to be fault tolerant if you're going to be using our spot instances. One of the key aspects of spot is to be instance flexible. So that means if you can use a bunch of different instance types and sizes, you are much better off and always going to be having something to replace what you've lost. So those are spot instances, 90% off, but with the caveat that you need to be well architected for fault. So maybe the question is, well, which workloads are good for spot, right? And so these are the workloads that we actually would consider that you might want to consider using spot for. I'm not going to go across all of them, but I'm going to talk about big data, for example, because we'll have a thread running through the rest of the presentation around big data. Usually there's going to be a very simple way to rebalance in terms of big data. So if you lose a spot instance, it can come back. So it's stateless and kind of fault tolerant, if you will. And one thing you'll see across all of these workloads that we're putting on this slide, CI/CD or parallel batch workloads, they're all going to be stateless and fault tolerant. And so, so basically containers, for example, as a technology is great to put on top of spot because everything is stateless by nature. And so if you lose a certain container, you could rebalance and bring up another container on a new spot instance. So spot instances are great for stateless and fault tolerant workloads, and these are the ones that are specifically great. We talked a little bit about interruptions. I talked about that 2-minute warning and then us actually taking something back, taking one of those instance types back, right? The truth is it doesn't happen as much as you might think. Basically, in the last 3 months, less than 5% of all Spot instances were actually just interrupted by us. Mostly it's just a customer finishing their work and turning it off. But there are techniques and actually tools to deal with interruptions. First and foremost, there's a CloudWatch event that is triggered when the 2-minute warning notice is going out, and that gives you 2 minutes and ample time to checkpoint, drain an ELB, spin up a new instance, etc. We've actually gone even further with some of our container implementations, so our managed services EKS and ECS, where there's already a connection that basically allows for quick termination, draining, and rebalancing at that kind of notice. So we've automated some of that for you in certain instances as well. So handling Spot interruptions is not quite as hard as it used to be. So that's kind of our pricing models. We went through savings plans and Spot. Let's talk a little bit about capacity optimization. So before we totally jump in to auto-scaling groups as a capacity optimization, how to blend pricing models in there, that's really what we're talking about, is blending pricing models for your workloads. And so what I want to show you is kind of the different workload types and purchase options and kind of what our most advanced customers do today with obviously different risk profiles. So I'm not going to go through each of these because it's quite a dense slide, but I want to focus on the middle one, which is analytics, ETL, and batch, which again, I told you we're going to run through a big data thread on this. And so in that case, it's a really interesting one because you can see the bottom part of that, those master nodes are on RIs or savings plans. So we recommend that those are steady state. If it's not an ephemeral cluster, like make sure that those are always on, right? And then you might have an SLA you need to meet, or you might have, for example, core nodes that you don't want to go down either. Put those in on demand, right? Those might scale up and down, but like make sure you don't lose them ever. And then finally, all of your worker nodes in the big data world, the things that are actually going to be doing the kind of heavy lifting and processing, you can put those on Spot instances. So this is a great workload example of how you blend 3 different pricing models to actually accomplish your task on a certain workload. So let's talk about kind of one of the ways that that's accomplished, if you will. And that's through EC2 autoscaling, so autoscaling groups. What autoscaling groups do best is they allow you to dynamically scale your capacity up and down to make sure that you are optimized. They make sure that you basically aren't using compute when you don't need it, but they also make sure that you're blending pricing models so that you're optimizing your spend on your kind of, let's say, per core hour, all right? And so the cool thing about this is obviously on autoscaling groups, RIs and savings plans, those discounts are automatically applied. And then we've actually kind of built in different functionality over the course of the last 4 years, and we'll take you through a little history here to allow for customers that want to use a lot of Spot, for example, and they can make sure they're hitting the most, where there's the most capacity, so the least amount of interruptions possible. We've also made it possible to spin up the lowest cost of compute possible for yourself. And then for those advanced users who really want to weight something, we have the prioritized list. So let's go through a couple of those just to help you understand a little bit more about autoscaling groups. So just from the journey perspective, this is what we learned from the customers. We used to have autoscaling groups. They're very innovative, again, from a scale up, scale down perspective. But one of the things we saw was customers trying to hack together the different pricing models. And so from this slide, what I'm really just showing you is before we had all these smart kind of optimizing customers who were using multiple autoscaling groups. So if you look at this, you've got the orange layer, the blue layer, and the red layer. And what they were doing is blending 2 types of Spot instances as well as an on-demand instance. And they were putting these 3 different autoscaling groups together to maximize their price, right, and maximize their spend. So what we did was there was just no clean way to kind of leverage Spot instances here and on-demand and RIs in a single group. And so we just changed that up. We learned from our customers and said, hey, we're going to change that up. And so what we did is we actually allowed now for all of those 3 purchase types, or 4 in this case with savings plans, in a single autoscaling group. What we really hope for the customers is that basically this makes capacity management and cost optimization just a little bit easier in terms of scaling up and scaling down, but also that you can ensure that you have a base capacity filled with kind of maybe something more steady state, and then a spiky capacity filled with something like Spot. So then let's talk about weights, and this will just more help you understand kind of auto-scaling a little bit. Let's say you have an SLA that you have to get to, or just an instance type where you think that your workload actually performs much better. In this case, what you're really seeing is you're just seeing auto-scaling group with weights. So in this case, the bottom right, you see an M44XL on demand that the customer really wants. If you're spinning up an auto-scaling group, they want more than half of that basically to be in that kind of type whenever possible. And so you can kind of see that what this is doing is basically just making an auto-scaling group that is more perfectly optimized for whatever workload they have. And so I would call this a little more advanced. And then finally, we have the capacity optimized strategy. This is really mostly for heavy Spot users. So it's more only if you're going to think about, really want to think about Spot and then kind of minimizing interruptions. And we just allow you to basically specify a capacity optimized strategy. And all that really means is that we're going to go and find the deepest Spot pools with the least likelihood of interruption for you so that you don't have as many interruptions. I should say that like auto-scaling groups, Spot, these are all available with different third-party integrations internally and externally. So internally, for example, at AWS, Amazon Elastic MapReduce, and I'll show you that in a second, integrates auto-scaling groups perfectly, as well as Spot. And then externally, we also have partners like Qubel or CloudBees, which runs Jenkins on the CI/CD side. Basically, they integrate auto-scaling groups as well because they kind of understand how to optimize the capacity for their customers. And let's talk about guidance just very quickly. This is mostly going to be through the lens of one product we released in 2019 at reInvent, and that is AWS Compute Optimizer. Compute Optimizer basically just uses, this is the easiest way to think about it, is it uses machine learning models, trains on millions of the workloads that we see actually on AWS and EC2. And it looks at stuff like resource utilization, configuration, performance data. And what it'll end up doing is making 3 recommendations for you to see if your instances or your auto-scaling groups are right-sized or not. And so looking at your footprint, it just makes 3 recommendations on changes you possibly can make. What we've seen is a customer save up to about 25% off what they're currently doing with Compute Optimizer. Coolest thing for you all, and the takeaway for you is that Compute Optimizer is free, and it's actually just available in the AWS Management Console. So if there's one kind of quick takeaway outside of the kind of refiguring your pricing models and everything, I would say that the quick takeaway is you can go and use Compute Optimizer today just to go and see if you're right-sized in currently what you're doing. And that gets us to our kind of workload section. So I had mentioned a little bit about analytics, DevOps, and then a little bit about web apps, and then blending pricing models. So let's just go through kind of what that looks like at some high-level architecture. So big data. As you can see in this slide, the main thing here is that this is a Elastic MapReduce EMR workload. And we'll harken back to what I had said before. So what you'll note here is obviously in the upper left, you have kind of the master node. As you can see, we recommend putting that on either on-demand, RI, or savings plans in this case. So something that's steady state. And then on the right-hand side of the slide, you kind of have your instance fleet. So these are your core nodes that are writing to instance stores, reading, et cetera. And basically, those core nodes, they should also be persistent. So you should definitely put those on OD or RI. And if you remember back to my little stacked graph, so that's what this is, right? And then you have your task fleet, and that's the lower left of this slide. And those can all be on Spot instances because they can be rebalanced. Now, clearly, there's a couple of caveats in here, but this is like what we see kind of like smart architecture looking like today in the well-architected environment with combining these different pricing models. So that's a big data workload example. Let's go to CI/CD. DevOps actually looks a lot like big data. I'll call out some differences, right? So obviously, first, it's behind an application load balancer, the ALB. It's going to scale dynamically based on traffic. And then what you also can see here is not unlike the kind of core and masters, you're going to have these Jenkins masters on the left-hand side, right? And in this case, in 2 different availability zones, but let's just keep it, you have the Jenkins master. Let's put those on OD or RI or savings plans because they're a little more steady state. But then You can create an entire Spot fleet with Jenkins agents all running on Spot. Again, if they get lost, it'll rebalance and checkpoint and keep going. So that's a CI/CD reference architecture that we see today a lot. And then let's get to websites and web applications. These are always got to assess how mission critical they are. So if they're mission critical, like let's make sure that like you never put that much on Spot. Do not recommend that. But running web applications with Amazon in the container state, so in this case ECS on Spot, looks a lot like this. Instead of an ALB in this case, an application load balancer, we have the ELB or the Elastic Load Balancer. Behind that scales traffic, that'll obviously scale traffic up and down or create containers. And in this case, what we've done is we just have two different types of containers. We have containers that are on demand and containers that are on Spot. And so in this way, you actually blend kind of your potential to lose instances, but you actually also have basically cost optimized uptime or capacity. And that's web applications. So key takeaways. Probably not going to go through all these. The main takeaway you should have got from the first half is basically that, look, we have tons of instance types and sizes, 300 plus, and so we're really ready for any workload you got. We also realize that's a little complex, and we're here to actually try to help you figure out how to optimize your capacity as well as pay the least as possible, right? But we want you to have your business to do very well. And so the two ways to do that in our newer kind of pricing models are basically savings plans and Spot. And then lastly, using EC2 auto scaling there will really help you dynamically scale up and down while choosing the right price models. So your cost per compute per hour is great, and you're not overutilizing. Compute Optimizer is the first thing you should do. So this is number 4 here. You can just do that right now after you listen to me. And then last, if you want to go deeper into any of my kind of quick 30-minute overview on this, what you really should do is go visit the AWS.training learning library, and you can dig into any of the pricing models, but also I would severely recommend you dig into kind of auto scaling groups. Matt Thompson, thank you very much. That has been Optimizing Compute. Take care.